Welcome to qnawire.
So here subscript I denotes initial and F denotes final. So we have the final mass to be half of the initial mass and the final radius to be 1% of the initial radius, and this is equal to 0.01 times the initial radius. Now omega I, or the initial angular velocity, is 1 revolution in 30 days. And let's first convert it into radians per second. So one revolution is basically 2 pi radian, and in one day we have 86,400 seconds. So here we have our initial angular velocity in units of radian per second. Now, since the total mass carries away no angular momentum, the angular momentum of the remaining mass will be same as the initial angular momentum. First, we write Li to be equal to Lf, which means that the angular momentum is conserved because there is no external torque. This gives I equal to II omega I to be equal to If times omega f. From here we can write an expression for the final angular velocity. So this will be equal to initial angular velocity times the initial ratio of the initial and final moment of inertia. And since the mass is a sphere, we know that moment of inertia of a sphere through about its center is equal to 2 by 5 times half 2 over 5 times half, sorry, 2 over 5 times m r square. So we use this expression over here. So I is 2 over 5 mi times ri square over 2 over 5 mf times rf square. So 2 over 5 cancel out, and now we write mf and rf in terms of mi and ri. So this will be equal to omega I times mi ri square over 0.5 mi times 0.01 ri square. Let me write the final expression on this page. So omega f will be equal to omega I times 2 times 10 to the power 4. And this is basically solving this part of the equation. Now we will use omega I, the value that we found here, in this equation, and we get omega f to be equal to 4.848 times 10 to the power minus 2 radian per second, and this is the value of the final angular velocity. And since time period is 2 pi over omega, and let's write 2 pi to be nearly equal to 6 over omega. This is like an approximation. This means that Tf will be equal to 6 over omega f. And since, so I think this, okay. So we might not need to simplify this. Okay, so let me just start again from here. So this, from here we can write that Ti over Tf is equal to omega f over omega I. This means that Tf is equal to Ti times omega I over omega f. And omega I over omega f is basically 1 over 2 times 10 to the power 4. So from here we can say that the period would be 20,000 times smaller than the initial period. And this will make it about 130 seconds. So let me just write that. Okay. Now the ratio of the angular kinetic energy of the spinning mass will be as follows. So we know that rotational kinetic energy is half times I omega square. So kf over ki, f means initial and f means final and I stands for initial. This will be equal to the respective I omega square, half of I omega square of both. Now we again solve this equation. We already know what will be II. So basically this IF will be the denominator. We know omega I and omega F. We know the ratio. We can simply use the ratio 2 times 10 to the power 4 here. And we get this value to be 2 times 10 to the power 4. This means that Kf is equal to 2 times 10 to the power 4 of Ki. This is what exactly we got over here.